Hey guys, today we're going to talk about writing electron configurations. So the last video that we watched ended up showing us the different orbitals and the different sublevels in addition to the shapes that they can take. Instead of showing pictures every time that we see an element, we can also identify them based on something called an electron configuration. So this can be a long version or a shorthand way of indicating which element we're looking at without giving characteristics such as the chemical symbol, the atomic number, etc., etc. So hints that the periodic table gives us. Remember, the periodic table gives us a lot of information about the elements. We can now look at the table in terms of their orbitals. So the first two columns, and helium over here, he is included in this first column, so let's pretend that he's over here. The first two columns make up the S block orbital, and the S block are those spherical shapes. The 6 columns over here make up the P block orbital, which are those dumbbell shapes. And remember, there are 3 possible dumbbell configurations: the x-axis, the y-axis, and the z-axis. So we can fit up to 6 electrons in there. Then the transition metals, these are the d orbitals, which end up making those clover shapes. And when we get to level 6 and 7, these are the f orbitals, and those are the ones that are really, really strange, have the funny shapes, the funny characteristics. Now in these parentheses it tells us our n numbers. So our orbital is the period number for the s blocks. The p blocks are the same, the orbital is the period number. Now remember when we said in previous units that the transition metals get weird? Well, this section, this d orbital, actually belongs to the 3rd level. So as we go through and fill electrons, we fill the 3s1, the 3s2, the 1st and 2nd electrons in the 3rd level. We go and fill the 3p's. We go to the 4s's, and then we go back and fill extra space in the 3rd orbital. So these 10 metals actually belong in the 3rd orbital. Then we jump back up to the 4th, up to the 5th, back down to the 4th, across to the 5th. Now on the periodic table in class, I don't have this little shift drawn in because I'm hoping at that point you're not going to need it. But we will be reviewing this and we will be talking about this in class before then. So remember, the first 2 columns are the s orbits. The 6 columns over on this side are the p orbits, and the transition metals in the center are the d orbits. So remember, we fill in the orbitals the same way we read. We start at the top and work our way across. So the first orbit we fill is the 1s. Then we go down a level, and the next orbit we fill is the 2s. Then we go across and fill the 2p's. Then we fill the 3s, and then the 3p's. And then once we hit the 4th level, we fill the 4s first. So I'm going to write 4s. But remember, this funny jog right in the middle goes back to the 3rd level for this d orbit. So this is the 3d, and then we jump back up to the 4p, and that ends us at the end of this row. We go back to the 5s's because the s level always has to be filled first, the 4d's, and the 5p's, and that's reading straight across here. Now we go to the 6s level. 6s is filled first, and then this block at the bottom, we actually jog down to here, and then jog back up to this location. So this f block is n minus 2. So that is actually the 4f. Then we jump back up to here, which is n minus 1, and since n is 6, this is the 5d level. Then we go back to the 6p. Then after 6p, we have the 7s, and 7 minus 2 is the 5f level, the 6d level, and then the 7p level. So if we fill all the orbitals, this is the order that we're going to go in. But on the test, I'm not going to provide this to you because I expect you to remember, start from the top, just like reading a book. So again, here are rules to filling the orbitals. The first rule is you must always fill the lowest orbital first. And again, here's the list of the orbits in order. The second rule is up to 2 electrons can occupy a single orbit, but only if they are spinning in opposite directions. So we did the hog hotel activity in class yesterday, and when we did this activity, you had to place the hogs facing opposite directions. Another example I like to use is a shoebox. When you put high-heeled shoes in a shoebox, you have to face them in opposite directions. You have to have the heel of one on the bottom of the shoebox and the heel of the other on the opposite side. If you put them facing the same way, they'll never fit. After that, you must place all electrons in that sublevel facing one direction only, then you add an arrow in the opposite direction. So again, just like in Hog Hotel, the pigs were too lazy to walk up the steps, and they only did that when all the rooms were completely full, and they were full with 2 occupants. So just like at your house, if there's another room available, you're not going to share a bedroom with your siblings. You will move into the extra bedroom, and you will fill in the rooms until they're completely full, and then if another child comes along or if somebody is adopted, then maybe you'll double up on bedrooms, but you fill in all of the empty rooms first, then you go back and fill in a second roommate. Our electron configurations indicate the orbitals that have electrons in them, as well as how many electrons are present. So there are 2 ways to write the electron configuration. The full configuration, which is every single orbit, every single electron, 1s2, 2s2, 2p6, 3s2, 3p4. Or you could write the noble gas configuration, where you actually go up a level and use the noble gas as a shortcut and only fill in anything after the noble gas. So I'm going to show you a couple examples so you can see what the difference is. Full electron configuration for magnesium. So magnesium is in 1, 2, the 3rd level, and it is in the first column, which is the S column. So I know I have to fill up until 3s. So first I have 1s2. That's hydrogen and helium's electrons accounted for. I have 2s2, that's lithium and beryllium's electrons accounted for. I have 2p6, boron through neon, and then I have the 3s level, and I have 1, 2 electrons in the 3s level. Now, in a different color, oxygen is this one I accidentally crossed out. So this is the 1, 2 level, and it's in the p orbit. So I can automatically fill in 1s2, 2s2, because I know I'm in the 2p, so everything before me has to be filled. 1s2, 2s2. And then I'm in the 2p level, and I have 1, 2, 3, 4 electrons in the 2p level. So one last time, I'm going to switch colors one more time. Iron is here in the transition metal section. So this means I have to be careful for a couple reasons. I'm in the 4th level, but remember this funny middle section, that is always 1 level less than what you think. So I can automatically fill up to 3p because I know I'm in the 4th level. So I have 1s2, 2s2, 2p6, 3s2, 3p6. And that accounts for all of these electrons that I'm putting X's over. Now I'm in the 4s level, and that's full, so 4s2. And remember, this jump goes down to level 3. So I'm in level 3D, 1, 2, 3, 4, 5, 6. So the full electron configuration, you write every single sublevel with all of the electrons in it for the entire element. Noble gas configuration is a heck of a lot easier. So I'm going to rewrite the magnesium full electron configuration. 1s2, 2s2, 2p6, 3s2. And neon is a noble gas that is above and all the way to the right of magnesium. And neon has a full configuration of the 2p6 level. So instead of writing these first three, I can just replace it with Ne, and that cuts out this entire section. After I cut that section out, all I have to do is write what comes after it, which is the 3s2 level. So I'm going to do the same thing with oxygen. Oxygen's right here. If I go up a level and all the way to the end, my noble gas configuration is helium. So oxygen's full configuration is 1s2, 2s2, 2p4. And helium replaces this 1s2. So I have to rewrite everything after helium. So helium's right here. The 2s level came next, so I had to include it. So when you have smaller or earlier elements, it doesn't necessarily make sense to do noble gas configuration, but for iron, it's really, really handy. So with iron, we're right here. If I go up a level and all the way to the end, I'm with argon. So iron's full configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d, 1, 2, 3, 4, 5, 6. And argon is at the end of the 3p level. So I can cross off all of this section and just write Ar, 4s2, 3d6. And that would have saved me a lot of time if I would have done that in the first place. So when you come to class tomorrow, we're going to practice with electron configurations. We're going to use three things to indicate our elements. The first one is our arrow diagrams. And those are what we look at, just like the hog hotel with the shapes or the directions of the pigs. The second thing is the full electron configuration, the really long way of writing out all of this. And the third way is noble gas configuration. So all three of those we're going to practice with when we come to class tomorrow. See you then.